BFS means breadth first search. Breadth first search. It use Q-U-E-U-E. Q uses FIFO, first in first out. How BFS works? Let's see with the visualization. There are 8 vertices. Edges are 1, 2, 6, 7, 0, 0, 3, 4, 5. So 0, 2, 1, 6, 7, 3, 4, 5. This is the graph. Okay, so we need a Q. Okay, let's start with 0. And we need a visited. Let's start with 0. Append 0 to the Q and append 0 to the visited. Okay, and now what? Search for all its neighbors 2 and 3. Append 2, append 3. Okay, now 0 is done and two and 3 is also visited. Now we have already visited all the neighbors of 0, so delete 0. Okay, 0 is done. Now there remains 2 and 3. 2 neighbors 1, 7, 6. 1 also visited, 7 visited, and 6 visited. Okay, now 2. Okay, 2 neighbors are visited, delete 2. Now remain 3. What is the frontier of the Q? 3, first element. So 3. What is the neighbors? 0 and 0 is the neighbor. 0 is already in visited, so 3 is done. 1. What is the neighbor? 2, already in visited, so 1 is done. 7. 7. 2 is the neighbor, but 2 is already visited, so 7 is done. 6. 6. 2 is the neighbor, 2 is already visited, done. So this traversal is done. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 elements are visited. Now this done. Now let's start from enter 4. What is neighbor? 5. So 4 is visited, 5 is visited. Okay. So 4 neighbors are visited. 5 neighbor is 4, but already in visited. So done. this is our output, the visited list. Result, the program output will be 0231764 5. We see the traversal is labeled first this, then this, okay, and here level wise. So this is breakfast or level wise traversal. Let's see the algorithm. So first we already see v equal 8 as are given. We use default dictionary which creates list if the values are empty or key is not present. This is imported by from collections import default dictionary. Okay, adjacency list maker. Vertex edges. Okay, we will create adjacency list, pass vertex and edges. Now we have already seen we maintain a visited array. So we initially assume all are not visited, so falls into the result. That's what we return. Initially the result is empty list. BFS level 1, we pass what? We pass visited and result. Okay. In BFS level 1, we pass every vertex and check whether it is already in visited. It is basically used for separate, non-connected components. So if we pass this, then these are all visited, and if we pass this, these are all visited by BFS level 2. Level 2. And finally we print result. So what we need to see? We need to see adjacency list maker. We have to see BFS level 1, BFS level 2. This creates adjacency list structure. That means this is an vertex and this neighboring vertices. We assume that every whatever you see this is not already visited, so if I is not visited, the vertex is not visited, then we pass it to for the actual BFS algorithm. So BFS, this is actual BFS algorithm, it is BFS 11 to 30 plus visited. This is the I acts as a source and this is result. We pass these values because that will get changed. Okay. Why we take Q0? Because we first element. we search the neighbors of the first element because this is a BFS traversal. So Q0, first element of this is a Q, so we have to find the neighbors of the first element. Okay? And when it is done, we delete it. So for neighbor in adjacency dictionary Q0, okay, and there is some code and we have to delete it after deleting all the neighbors. So delete UUE Q0. Okay. So this element is deleted. And now what we do? Look there. Neighbor. If the neighbor is already visited, then we ignore, but if not visited, that means it is false. We can keep the neighbors. As we add the neighbor into Q, we also assume visited. It is now visited, so visited neighbor were true. Okay, and whether we also the result because it is visited now, so result has to be appended, that neighbor has to be appended with the result. Append neighbor. That's it. So while Q for neighbor in adjacency dictionary of Q0, that means this is the first element or 0th element. So if append all its neighbors in case it is visited, we ignore it, and if it is not visited, we append to the Q, and when the neighbors are all visited and the result is appended, we delete it. Okay. And how long this process will then we move to this element. How we move to this element? This is deleted of which element has become first element of the Q or 0th element of the Q. This. And again go to Q0 and Q0. How long is all the elements are born from the Q. Result. So BFS is done. Let's do some analysis of BFS. What is the time complexity? Big of vertex plus edge. Why? Because we visit every vertex once. Why once? Because we maintain a visited array and no deleted twice. So big of E. And why E? Because every vertex is deleted once. So one edge is also deleted once. So vertex plus edge. What is the space complexity? Big of 2 D. Why? Now because we maintain a Q. What is the maximum size? It can be V. The maximum size can be V, and we also, this is a Q here, and it also maintains another list called visitor, and this takes also V, because ultimately all elements are visited, and V is known, this size will be V, this maximum size will be V. And if we also consider the result array, then this will be V. Then we can consider 3D. But as 3 is a constant, simply says big of V. This is the space complexity. Now what is the advantage? Advantage number one, this is an easy method to implement. Number two, it always finds the shortest path. Always finds shortest path from starting to target. Number three is for undirected graph. BFS often behaves similar to BFS or depth first search. And now let's see the disadvantages. For directed graph, BFS is more efficient than BFS to detect cycles or and strongly connected components. Because BFS goes depthwise, it can easily detect a cycle. Okay. But BFS goes breadthwise, so cycle detection is not efficient.